In this problem, it asks us to use Fleury's algorithm to determine an Euler path in the graph. And so I've drawn a larger version of it here, and it says, for Fleury's algorithm, the first step is to use Euler's theorem to determine whether an Euler path or an Euler circuit exists. And if one exists, then we go on. So I'm going to find the degree of each vertex. Vertex A has degree 2 because there are 2 edges coming into that vertex. Vertex B, we have 1, 2, 3 edges. So that is degree 3. C is the same. That's also degree 3. And then D and E are both 2. Since there are 2 odd vertices, that tells us that there is an Euler path, but no Euler circuit. Okay, so we're going to complete the Euler path. We are starting at vertex C, so that's here. And we're going to go to A, and then to B, and then to D. So at this point, the only choice I have is to go to vertex E. So that's going to be my next vertex in my list. Then my only choice is to go back to C. That's my next vertex. And finally to B. So we can look at the steps for Fleury's algorithm, but for the most part, you're just following the path that you need to follow. Sometimes there's only one path, like in this case, but if I had choices, then we look at the steps and it says begin to trace edges while moving through the graph. We can number the edges as they are traced. I just kind of outlined them. Either one is fine. Since edges can't be traced twice, we just want to keep track of what's already been traced. And then we want to choose an edge that is not a bridge if we come to 2 different choices. And then we get to the end of our graph, and that's how we got that. So that's how you do that problem.